Okay, so today we're just going to go through the exam questions. Ideally, you'll have attempted these questions already yourself, and then this video is going to take you through the answers. I know with the actual exam questions, things seem like it's a lot harder than when I just give you questions on the sheet, but the answers are exactly the same. They just tend to put a little bit more information into the questions, makes it seem a bit harder. But hopefully you will have been able to answer some of these questions. So the first one, which of the following metals is found uncombined in the Earth's crust? It gives you 4 answers. Your answer is going to be gold. Okay, gold is unreactive. Because it's unreactive, it's found as a pure metal. So hopefully you got that one right. The next one, we have seen this so many times. You have to complete the equation. You've got iron, you've got carbon. Carbon is more reactive than iron, so they are both going to swap places. And when they do, you are going to get carbon dioxide and iron by itself. If you wrote carbon oxide and iron, you will still get your 2 marks. So that's for 2 marks. Give yourself 2 marks if you got that. The next one, what happens to the iron oxide during this reaction? Again, it gives you lots of options. There's only one of these that we have seen during this topic, and that's the last one. Iron oxide is reduced. Remember, reduction is the removal of oxygen. If we look at what happens in that equation, iron on the left has oxygen. It loses that oxygen to form just iron on the right. So iron oxide is reduced. The oxygen is being removed from iron oxide to give me just iron. So if you got that right, that was another mark. So there's 4 marks in that first question on the first page. Then we've got D. You can get zinc either by electrolysis or by heating with carbon. So you can use either method. Because zinc is less reactive than carbon, you can use carbon. Give a reason for the method that's used. Okay, so you will use carbon instead of electrolysis purely because electrolysis is expensive. So you can use either method, but you'll choose the cheaper method, and that's the method with carbon. So if you mentioned electrolysis being expensive, give yourself a mark. Then we get down to question E. Now, you haven't seen anything like this before, but the answer is right there in front of you. Why is it more important to recycle tin than to recycle aluminium? Okay, in the first column here, we see the cost, and you can see that aluminium costs £1.31 per kilo, and tin costs £12.60 per kilo. So tin is more expensive. All you have to say is tin is more expensive. Therefore, it's more important that you recycle tin because it's more expensive, it's more precious. If you look at the amount in the Earth's crust, you will see why. 8% of the Earth's crust is made of aluminium compared to 0.0002, which is tin. Okay, so tin, the reason it's more expensive is because you got tin. There is, I'm going to write that as less tin in the Earth's crust. Okay, so tin, or you can write rarer, or you could write less common or less abundant. Okay, anything to do with the fact that tin is less common. That's why it's more important to recycle it than aluminium. Okay, so that's 2 marks. Scrolling down to part C. They've given you part of the reactivity series, and what they haven't included is they haven't included carbon. So you would need to know where carbon goes. So if you look at the reactivity series that I've given you, you can see that carbon is under aluminium, but it's above iron. They say iron is extracted. They tell you that you can extract iron from its ore by heating it with carbon. Okay, that tells you that carbon's more reactive than iron, but you need a different method for aluminium. The name of that other method is going to be electrolysis. You need to use electrolysis for aluminium because it's more reactive than carbon. Explain why aluminium is extracted by a different method rather than heating with carbon. You are going to tell me aluminium is more reactive than carbon. Therefore, it cannot be extracted with carbon. And you're going to use electrolysis instead. You could have written the other way around. You could have said carbon is less reactive than aluminium, therefore it cannot be extracted with carbon. But you just need to tell me that aluminium is more reactive than carbon, therefore carbon's not going to be used to extract it. If we scroll down to question 6, this is our last question, okay? They're talking about solutions and whether they conduct electricity or not. And then they want to know which ones are electrolytes. Now, this word electrolytes is in your notes, but I don't really think we talked about it in class. Electrolytes, okay, is just something that can conduct electricity. So if I want to see which solutions are electrolytes, I just need to look and see if they conduct electricity or not. J conducts electricity and K conducts electricity. So I'm going to write J and K. That's 1 mark for identifying which two. And then I need to give a reason. J and K are electrolytes. And the reason they're electrolytes is because they... Sorry, there's a little bit more to definition. Because they are ionic compounds that conduct electricity. Or you can say because they have ions to conduct electricity. You just need to mention the word ions in your answer as well. So these two conduct electricity, which means they're electrolytes, and I know they're electrolytes because they're conducting electricity. They're doing so because they've got ions. Which material is most suitable to make the electrodes for the electrolysis of a dilute acid? We said that when you had your electrodes, so reminding you that these pieces of metal here are your electrodes. In order to be an electrode, there are 3 things that they had to be able to do. They had to be able to conduct electricity. They had to be inert, and inert means unreactive. And they have to have a high melting point because it gets very hot. It gets hot and you don't want them to melt and become a liquid. Okay, so that's the criteria for an electrode. Now we need to look and see which one of these is going to fulfill that criteria. All right, you've got zinc. Okay, zinc is a metal, so it can conduct electricity, but it's not unreactive. Sulfur is a non-metal. It doesn't conduct electricity, so it's not going to fulfill the criteria. Iron, it's a metal. It does conduct electricity, but it's not unreactive. And then we've got graphite, okay? Graphite does conduct electricity. Remember, graphite is one of the forms of carbon. It does conduct electricity because it's got delocalized electrons. So it does conduct electricity. It's got a very high melting point and it's unreactive. It's what you find at the end of your pencil. So it's very, very unreactive. So your answer is going to be graphite. If you got that, give yourself a mark. Any questions about anything that I have done here? Message me on Teams. We can have a chat about it.